Hey there, hi there, ho there. Welcome back. It's great to be back in the home office here. So, we're now going to start to tell the story of Earth, starting from the beginning, 4.5 billion years ago, all the way to, the present as best we can. So we've set a foundation. Now we're really going to again uncover that story of Earth. So we're going to first talk about the Precambrian, which is a big chunk of time, but we're going to focus in on a couple of eons, the Hadean and the Archean eons. At least for this unit, next unit will still be in the Precambrian, but we'll get into a different eon, only because there's just so much time in the Precambrian. So if we're looking at the geologic timescale, and this is a very detailed geologic timescale. Visually, we see, the Precambrian, and then we have the Paleozoic, Mesozoic, and the Cenozoic. Well, okay. Those all kind of look, these are all, these all look like, it's about the same amount of time because the columns are about the same height. But if you look at the numbers, they're not. So the Cenozoic goes from now, currently, to about 66 million years ago. So this represents 66 million years. This represents 66 to 252 million. So this represents almost 200 million years. This represents almost 300 million years. And this represents almost 4 billion years. So this doesn't do a good job visually of telling you how much time is here. You have to start to look at the numbers. But for this unit, we're going to focus on the Precambrian, the Hadean, and the Archean eons, and then we'll look at the Proterozoic eon in Unit 8, and then we'll kind of look at these successive units throughout this semester. So this might be a little bit better visually, looking at the Precambrian, again, extending from the beginning of the Earth, 4.5 billion years ago, to about 542 million years ago. The reason it's called the Precambrian, let me go back here, is because after the Precambrian comes the Cambrian period. So the Precambrian is everything before the Cambrian. A lot of stuff happened in the Cambrian. That's why it's so special. So we have all this time, which represents over 88% of all of Earth's history is contained in this Precambrian. But again, we'll just focus on the Hadean and the Archean for this unit. The Precambrian, as mentioned, is more than 4 billion years of history. This is a pretty big span of time for us to kind of think about. So I've given you this analogy a few units back. So this is $10,000, $1 million, and $1 billion to illustrate how much more a billion is than these other things. But we're talking about over 4 billion years of history. 10,000 years ago, that's before the ancient Greeks, that's even before the ancient Egyptians. So to us that seems like a long time. However, 4 billion years, that's a lot of time. So fortunately and or unfortunately, because this stuff is so old, all of the earliest geologic records, all this stuff preserved in rocks, is kind of difficult to interpret because many rocks of Precambrian age have been altered due to metamorphism, completely deformed, buried under younger rocks. The fossils are pretty rare, and even going further and further back, a lot of those early first rocks were recycled and destroyed due to plate tectonics. So there's not a lot of information, which is, I guess, good and not good in some aspects. So we can kind of knock out a really big chunk of time. So the three eons in the Precambrian, again, are the Hadean and the Archean, so we'll focus on this unit, and then the Proterozoic, which we'll focus on again in the next unit. So this is what we're going to focus on, at least for right here and right now in this unit. Seems like a lot, and it is. I mean, that's 33, 44, almost 45% of all of the Earth's history in this one unit. But, again, there's not much left, so we have to interpret how we can. So in the Hadean Eon, which was from the beginning of Earth to about 4 billion years ago, no rocks of Hadean age are present on Earth that we're 100% sure of, except for meteorites and some minerals. Again, due to plate tectonics, these things were recycled back into the Earth. So we don't have any rocks from this period that we know of. Again, we have some minerals, different than rocks. We have meteorites, those came from space. But earth rocks, we don't got much. As far as the minerals are concerned, there are some sedimentary rocks in Australia, more on Australia throughout this unit, that contain detrital zircons, weathered and eroded zircon minerals, dated at about 4.4 billion years ago. They're not rocks, but they're minerals. But minerals have to come from somewhere. So we know the source rocks for these minerals have to at least been that old. So we know there had to be rocks. We just don't have those rocks. Those are long gone. So again, due to evidence like this, and what we can see happening elsewhere, in the galaxy, and we looked at the formation of our solar system based on what we can see elsewhere happening, we can kind of put all of this stuff together. So we know there had to be rocks, just we don't have them anymore. So in the Hadean Eon, that includes Earth's initial formation. That was due to accretion in the solar nebula. We have the differentiation and stabilization of layers, so the core and the mantle and the crust formed once bombardment had slowed down. There had to be abundant volcanic activity in the Hadean Eon, and the oceans and atmosphere actually began to develop in the Hadean as well, because about 4.4 billion years ago, Earth cooled at least sufficiently for surface waters to accumulate. But the atmosphere of the Hadean was quite different than that of today. Additionally, impacts were still going on from space, and so there are enormous amounts of heat that prevented much of the rock from solidifying at the surface. Not only the heat from the impact, but the internal heat from radioactive decay and from formation really prevented a lot of rocks from forming anyway. All right, there were some, because the zircons exist, but for the most part, probably, the early Earth looked like this, which really prevented a lot of rocks from forming. Once oceans and atmosphere developed, perhaps it might have looked like this. Volcanic activity, we have bombardment going on. The moon was a lot closer. The atmosphere was a different consistency, so it would have looked different light-wise. And we begin to get these structures forming close to, 4 billion years ago, as well as we get to the end of the Hadean Eon. More on these, but these are known as stromatolites. So what the lithosphere looked like in the Hadean transferring into the Archean was probably a little bit different. Again, once bombardment started to slow down, more rocks can form, more crust can form. So we see kind of a different lithosphere, the hard stuff, the crust in the upper part of the mantle, that we would see from the Hadean to the Archean. Again, anything from the Hadean got recycled, plate tectonics, so we don't have any of that. But as we get into the Archean, from about 4 billion years ago to 2.5 billion years ago, we do start to get rock evidence. We start to get fossil evidence as well. So that's pretty much it for the Hadean for the most part. But as we get into the Archean, continental crust began to be present about 4 billion years ago. That's what kind of marks the difference between the Hadean and the Archean. Earth's oldest rocks, and I mentioned this in the past, the cast ice up in Canada is about 4 billion years old. So some of the original crustal material is the oldest that we have left. The oldest rocks, if you're curious, in the United States is the Morton gneiss, and it's the oldest intact continental crust rocks in the U.S. This is just kind of a fun little what have you. But due to geologic collisions, this material was kind of brought close up to the surface. The rock was exposed, because this is lower down rock, metamorphic rock. The rock was exposed due to glaciation, as well as rivers cutting through, so weathering and erosion cutting through a particular area to expose some of these red rocks. Again, the Morton gneiss. Gneiss is a metamorphic rock. It's altered granite, typically. So just for funsies, this is the oldest rocks in the United States. These little outcrops are all of those exposed gneisses. The river is kind of over this way. So glaciation and again, river weathering and erosion help to expose these rocks. So gneiss is a foliated metamorphic rock. Foliated has lines or layers. So we see these kind of banding of minerals when kind of granite-like rocks were kind of compressed in a particular direction to align these minerals. Close up, we can kind of, this is just a close up of what we're looking at over here. The town's super proud of this rock. They used it for, you know, their welcome to the city sign. You know, this is where they kind of mine out large slabs of these rocks. They use it for other decorative purposes in their buildings. And what I thought was kind of cool is that they took a slice of these rocks and they were actually used, I think in the 1950s, they took some slabs of these rocks, the oldest rocks in the United States, and they turned them into fountains just outside the White House, just outside the ellipse. There's two of them. There's one here and one on the other side. If you kind of turn to the right from these, you'll see the Washington Monument. So they're kind of between the White House and the Washington Monument. The Washington Monument would be over here, White House here, and there are those fountains made of that Morton gneiss. Anyway, that's just kind of a fun little side note. Sorry for the little glitch. So, looking at the United States, again, not the oldest rocks in the world, but just to focus in on where we live a little bit. So the red are some of these oldest Precambrian rocks. I think that Morton gneiss is right here in this area. So again, remember the Precambrian spans a pretty big chunk of time. So there are some rocks that, you know, are into the hundreds of millions and billions of years old. But at least in the United States, the oldest rocks are that Morton gneiss. But if you look here in Arizona, we still have plenty of Precambrian old rocks, including some right around us here in the Phoenix area. All right. So I tell you what, let's go ahead and pause here for this first section. There's still a little bit to go. We'll finish that up. And so when we come back, we'll just finish up this first section, giving you a little introduction to the Hadean and Archean eons. I'll see you back here in just a second.